This is Nash Brenner.
This is Caitlin Christensen.
Ryan Lipdahl.
And this is the introduction to our friction project for the Newton's Laws of Motion. It is the 3rd of November on a Sunday. It is 7 p.m. and we are in period 5. Period 5.
Period 5.
Yes.
Oh, yeah.
Newton's first law states that objects in motion stay in motion unless acted upon by an outside force. And we can see this in this example. My partner here is spinning around from this force, but say if I go and use an outside force to interact, it changes the motion of my partner here. Do it again. See, it is an example of Newton's first law, as we can see, from my force that acted upon my partner's motion of spinning.
So, as you can see, I was stopped by this here seatbelt. It's pretty good. According to Newton's first law, if I didn't have the seatbelt, I would move until intercepted by this here, then the back of the seat, which would be potentially detrimental to my health. And, you know, it's much more safe to be stopped by this than this. This is much less detrimental to my health. At least I think so.
In the high five done by my partners, they have relatively equal mass and equally low acceleration, leading to low force exerted. Whereas in the second example, both partners have the same mass, but one has a higher acceleration, leading to a higher force.
This Sharpie has relatively low mass, and as I flapped my partner on the head there, I did it with relatively low acceleration. And according to Newton's second law, that mass equals force times acceleration, you can see that the resulting force of this Sharpie being flapped on my partner's head is low. Now, say if I were to use this book here, this big book, and were to this has relatively high mass compared to the Sharpie, and I did it with the same acceleration. So the resultant force of this book being flapped on my partner's head would be higher according to Newton's second law, that force equals mass times acceleration.
When you pull the cord out of the Beyblade machine, the cord pulls one way, and the actual Beyblade goes the other direction. The cord being the action, and the Beyblade the reaction. Also, when you put the other Beyblade in, when it hits, both Beyblades get pushed an equal amount to each side. The only thing that determines winning is how long that they can stay up.
If a snowmobile hits an object, it exerts an equal force on both the snowmobile and the rider. The job of the helmet is to protect the rider from said force to prevent any head injury.